Okay, so let's finish up this section. Accidentally stopped the video instead of pausing it, so you get 2 instead of 1. All right, I want to do one more example, but this one has a little twist to it. It has a discontinuity in the derivative. So y equal x to the 2/3 is a perfectly fine function from 0 to 8 for x. No problems there. We can plug in any of those numbers. But if we take its derivative, y prime, we get 2/3 x to the negative 1/3, which is the same as 2 over 3 x to the third. That is discontinuous at x equal to 0. So we can't use that function. It's problematic. So what we're going to do instead is we're going to solve it for x. So if y is x to the 2/3, raising both sides to the 3/2 power, we get x is equal to y to the 3/2. That is, and its derivative, which you can see down here, is 3/2 y to the half. And that's going to be fine. It's going to work on all of the y values that we need, but we do actually have to switch from x values to y values as well. So I just went back and plugged in 0 for x, because that was the first part of my first endpoint. And if you plug in 0, y is 0. If you plug in 8 for x, you get 4 for y. So I have this ready to go, and you can see here I started to set up the integral. We'll look at that in just a second. So I have the derivative of x with respect to y. It looks a little weird. It's kind of backwards, but that's okay. I squared it, and we get 9/4 y. Okay, the group drops out very nicely. So using the equation that we have for finding arc length, I have the integral from 0 to 4 of the square root of 1 plus that 9/4 y. Now we're doing this with respect to y. I integrated, so I raised the 1/2 power to the 3/2 power. I multiplied by its reciprocal. We do have a chain rule, so I multiplied by the reciprocal of that as well, giving me 8 over 27 times 1 plus 9/4 y to the 3/2 power, evaluated from 0 to 4. Very fun, very exciting. You can see here I plugged in 4 and 0. And if you clean that up a little bit, you get 8 over 27 times 37 over 4 to the 3/2 minus 1 to the 3/2. Now, 1 to the 3/2 is a piece of cake. That's just 1. But unfortunately, that 37, just like the last example with the 13, is really problematic. It's going to get in the way. So I just threw this whole mess into my calculator, and I got 8.04. So there you go. That's finding arc lengths. They can be messy. Clean up that radical first. See if you can do anything to make that look nicer, and then take it where it goes. All right, thanks.